Okay, students, so I'm going to now go over your practice one here. I gave this in class. And now I'm going to go over the work for each and every problem so that you know what I expect to see. If there's more than one way to do it, I'll point out a couple ways you can choose to do it. I'll just do one of those ways, but I'll verbally explain the other way if you want to do it that way. Okay. So here we go. Number one. Since the coefficient on both of these is 1, anything outside the parentheses is your coefficient that you need to distribute through there. Since they're both 1, I can just take off the parentheses right now if I wanted to. Okay. I could then just underline the like terms and add them together. Or if I wanted to, I could write the second one underneath the first one. Notice this is plus 1, so therefore positive 1 times anything inside is going to stay exactly the same. And then I can just add straight down because I've already got my terms lined up, and 5 minus 3 is positive 2. You cannot forget the signs. You can, if you want to, put plus there. You can never have just two terms that are just next to each other with no sign in between. Okay, as some of you have done in the past. All right, number two ways to do it. I could take the 6x squared and distribute it through all three terms here. Okay, and then combine like terms afterwards. Or I could sit there and see, oh, look at, I have combining like terms right here. I can combine those first, and 3, remember they're like terms because the exponents are the same with the same variable, x, called the base. So now I just put their coefficients together. 3 minus 8 is negative 5. That's just integers. So I have this instead that I'm now distributing the 6x squared through. And then I'd be done afterwards because there won't be any like terms. I took care of them already. So I have 6 times negative 5 is negative 30. Here on the outside I have 2 x's. On the inside I have 3 x's. And 2 plus 3 is 5. When I multiply like bases, the x's are like bases, I just add the exponents. And then I have 6 times 3 is positive 18. Do not forget the positive sign at x squared. And there's my answer. Can't combine them. All right, number 3. This says the quantity 2x minus 5 squared. So it's 2x minus 5 times 2x minus 5. I'll write out the shortcut. Again, I've showed you the shortcut many times. We've done it in class. Some of you memorize it and some of you don't. The shortcut is I square the first term. 2x times 2x, 4x squared. I take the two terms, multiply them together. So 2x times negative 5 is negative 10x, and double it. That makes it negative 20x. And then I square the last term. Negative 5 times negative 5 is plus 25. That's the shortcut. Now, many of you aren't going to remember that. Those you want to go into higher math, you want to memorize this. Save you time. Plus save you time for extra credit in class. When I put this on the screen for extra credit, you'd have it memorized right off and put down the answer right away instead of having to work it out like the rest of everybody else is going to have to do a long way. So if you don't remember the shortcut, you need to write out 2x minus 5 times 2x minus 5. And I have negative 5 times negative 5 is plus 25. Negative 5 times 2x is negative 10x. 2x times negative 5 is negative 10x. And 2x times 2x is 4x squared. And then I add straight down, and I get this same answer right here. Okay, so there's the two ways of doing that problem. Okay, now the rest of the problem, most of the rest of the problem, we're going to do on a separate page. So I think the first one is number 4. See right here, we have 3x minus 5, so a binomial, 2 terms, times a trinomial. So I'm going to take the smaller of the two, the binomial, and put it underneath here. So I only have to go through 2 rows and then add them together. Okay, if I put the 3x squared minus 8x plus 2 underneath the 3x plus 5, then I have to multiply out 3 rows and then add them together. So this is the smarter way to do it. Negative 2 times 5, negative 10. Negative 5, or I should have said negative 5 times 2. Negative 5 times negative 8x is positive 40x. Always have the sign every time, plus or minus. Negative 5 times 3x squared is negative 15x squared. Now that's the first row. I just dealt with that one. That's the first one. That's those ones right there. Okay. Now I deal with the second one. Put this through all 3. 3x times 2 is positive 6x. Put the sign with it. 3x times negative 8x is negative 24x squared. Remember, I have an x and an x. 1x times 1x is x squared. And lastly, I have 3x times 3x squared would be positive 9x cubed. 2x is here plus the 1 here. I add them to get 3. Now I have all my like terms lined up. I just add straight down. Don't forget the signs. When I add two negatives, I get a negative. I just add the numbers. 24 and 35, or 24 and 15 is 39. The base, the exponents do not change. That says x cubed, that says x squared. This one's going to say x. 40 and 6 is 46. X. These do not change. Only the coefficients do you add or subtract. And lastly, there. So there's my answer right there. Okay. Now, when you're doing it on the edge of Alaska, if you miss one of these terms, you don't have the 9, the negative 39, the 46, or the negative 10, you miss one of those, you get no, they aren't going to give you credit. Okay. Or they have a different answer as multiple choice and you pick the wrong one. Okay, so this one, next one is 6, some is 5. I'm going to do on the main screen. So again, I'm trying to solve for x. I look at the coefficient. Is that positive? Yes. So it's going to stay there. And I'm moving the constant across. So I'm adding 14 because I have to do the opposite operation. It cancels out. So now I'm left with 5x equals 14 minus 5 is 9. Remember, the smart way to say is you say the positive one first. You notice I didn't say negative 5 plus 14. I said 14 minus 5. You say the positive one first. Negative 1 second. It's easier to remember how to do your calculations. And last step, divide by 5 on each side. So the answer is 9/5. Okay, equals 1x. You're always solving for 1x. Okay, number 6. A lot of you don't like dealing with decimals. Okay, if you have no problem, I'll show this a couple different ways. So remember, we're doing reverse PEMDAS. Every time that we're solving for a variable, we're doing reverse PEMDAS every time. So is there something to add or subtract across? Remember, that means an entire term. If I'm adding or subtracting, I'm moving an entire term across. Remember the first question I asked. The coefficient of the variable, the coefficient of c, is that positive? Yes, it is. So it's going to stay there. So I'm moving this constant term across. So that's my add or subtract. To do the opposite operation, plus 5 to both sides. So I have 0.5c equals 12. Now, if you say this correctly, you can answer it in your head. Okay, to know what the answer is. So to how to say this correctly, you should be saying half, because that's 0.5, half of what number, that's my C, half of what number is 12. If you just think half of what number is 12, you should automatically be able to say it's 24. Half of 24 is 12. So the answer is already 24. Okay, now it's just showing the work for it. I could sit there and divide by 0.5 on both sides, and then a lot of you still don't know how to do that, because again, we're doing non-calculator here, but that would give you the right answer. Okay, another way is I could go ahead and multiply the entire equation by 10. That moves the decimal over 1. Remember, this decimal right here is 12.0, so now it becomes 120. So now I'd have 5c equals 120. Last step, divide by 5, and I get 24. Okay, so that's another way of doing it. Okay, the last way of doing it, and you just pick whichever one's easiest for you, is I change that 0.5 to a 1/2. And how do I get rid of 1/2? I multiply by the reciprocal. Half, the reciprocal of 1/2 is 2. Whatever I do to one side, I must do to the other side. Those cancel out, and I get c equals 24. So to me, that's probably the easiest way for most of you to do it. Change that decimal to a fraction, and then multiply by the reciprocal. Okay, but if you want to get rid of the decimal, you can multiply the entire every term in the equation by 10, because that moves the decimal place 1 over. Now you're no longer having decimals. All right, number 7 and 8 on this page. Okay, we're going to go ahead and distribute. So I get negative 40 minus 8x equals 22 minus 2x. Now I need to ask myself, which side should I bring the variables to? I always take the smaller one to the bigger side. Negative 8 is smaller than negative 2 because it's the left on the number line. So that means this negative 8x is going over there, which means the constant is going over there. So how do I move negative 8x across? To do the opposite operation, plus 8x. How do I move 22 across? The opposite operation, minus 22. That gives me 0, that gives me 0. So I get 8x minus 2x is 6x. Don't forget that minus sign there. And negative 40 plus negative 22 is negative 62. Remember the same signs, you add and keep the same sign. Last step, divide by 6. And I see that they're both even numbers. So that means I can divide by 2 at least. And that is the GCF 2. So I divide each by 2 and I get negative 31 over 3. And there's my answer. All right. Number 8, we don't have any distributive property, but we do have combined like terms. Nothing on the left side of the equal sign. There's nothing combined over here, so that stays. But over here, I have a constant here, and I have a constant here. Here I have a x term, and here I have an x term. So I'm going to combine those, combine like terms. So the left side, there's nothing to combine, so I just rewrite that one down again. The right side, I'm going to put the x's first. That's usually what you do in standard form. So negative 5x and negative 3x is negative 8x, and 2 plus 17 is 19. Okay, so again, I ask myself, which coefficient is smaller on the variables? Negative 9 is smaller than negative 8 because it's to the left on the number line. So I'm going to add that across, smaller to the bigger side every time. That way I count with the positive. So since the variables are going to the right, the constant must go to the left. The opposite of plus 19 is negative 19. Okay, then this wipes out, this wipes out. 9 minus 8 is 1x. That's what we're trying to solve for. So once we do the left side, we're done. Negative 9 and negative 17, or negative 19 and negative 7. Add the terms and keep the same sign. So negative 26. Now again, I'm not, to save time in the video, I'm not going to plug all these back in, but you could plug these back in your calculator to check that your answers are right. Okay. Number 9 now. Again, when I have a normal equation, it's reverse PEMDAS every time. Okay, you got to know that reverse PEMDAS, and you got to know those steps inside and out. Add or subtract first. Well, this variable is positive 1x there, so I'm going to leave it on this side. So I'm getting rid of the minus 4 to the other side. So I have x plus 4, all divided by 2 equals 5 minus 4 is 1. Now I want to get rid of that fraction. Okay, that divided by 2, the opposite divided by 2 is multiplied by 2. We're up at multiply and divide now. The opposite, whatever I do to one side, I must do the other side. Those cancel out. So now I'm left with x plus 4 equals 2. And the last step to solve for x, I need to get rid of the positive 4 to the other side, so I subtract 4. X equals negative 2. You can plug it back in. Negative 2 plus 4 is 2. 2 divided by 2 is 1. 1 plus 4 is 5. Here we have two fractions that equal each other. You must remember that's called a proportion. When I have more than one term in a numerator or denominator, I put parentheses around it so I don't forget when I cross multiply, because that's how you solve all your proportions. You can always cross multiply and it'll always work. Okay, I need to multiply through that entire parentheses. So I have 7 parentheses x minus 3 equals 2 parentheses x plus 4. Since 2 does not divide into 7 evenly, I'm not going to divide each side by 2 because I'm going to deal with fractions then. So now I'm just going to go ahead and distribute. Put arrows so you don't forget to distribute through both of them. Some of you might want to just do one arrow at a time. Do 7 times x, write it down, 7x. Then draw my next arrow, 7 times negative 3, negative 21. So you do not forget. 2 times x, 2x. Then draw my next arrow. 2 times 4, positive 4 is positive 8. Again, I ask myself, which coefficient on the x's is smaller? 2 is smaller than 7, so I'm going to move the 2 across, minus 2x. I always line it up on like terms. Since the variables in this case are going to the left, the constants going to the right. Opposite of minus 21, plus 21. Okay, so I get 5x equals 29. And last step, divide by 5. 5 divided by 5 is 1x. You're always solving for 1x. All right, number 11. Solve this in a graph. Again, I ask myself, which coefficient is smaller? 3 is smaller. So I'm going to subtract the 3x across. Let's get rid of that, what looks like a division sign. Just subtract 3x across, which means the constant's going to the other side. So add the 2 across. Gone, gone. I get 3 is less than or equal to 3x. And last step, divide by 3. Notice in doing this, I'm always dividing by a positive, so I'm not going to have to remember to switch the inequality sign. Okay? This is the smartest way to do it. Cut down your chances for error. So now I need to graph that. I remember I always read from the x side. X is greater than or equal to 1. So I put a 1 here. Okay, greater than or equal to. Since it's got an equal sign, I put closed circle. If there was no equal sign there, I put an open circle. Greater than. All the x is greater. Everything that's greater than is still right. All these numbers over here are greater than. Make sure you shade that in clearly so I see it shaded. Don't have a small one. All right, 12. Again, we have combining like terms and solving for x. There's nothing to combine on the left side, but here we have 6x minus 5x. 6x minus 5x is 1x. And I'll just rearrange this, put it in standard form. Remember, standard form is highest degree down. So I have an x to the first, it's degree 1. Remember, when there's no x there, it means degree 0, because I can always write that as 2x to the 0 power. That's why it's degree 0. Because remember, x to the 0 equals 1, and I'd have 2 times 1, which is still that 2 right there. So any constant is always degree 0. You need to remember that. All right, again, I ask myself, coefficients on the x, which one is smaller? 1 is smaller than 3. So I'm subtracting it across, the opposite operation, which means the constant is going to the other side. Opposite operation. Same steps over and over. I'm going to do reverse PEMDAS. You hear me saying the same thing over and over. -8, or I can say 2 minus 8, -6. 3 minus 1, 2x. Last step, divide by 2. Get x is less than -3. So now there's 0, there's -3, and there's no equal sign, so it's going to be an open circle. Less than, remember the arrow always points to the less than all the x's less than -3 are to the left always, so shade to the left. All right, 13. So solve the systems by elimination or substitution, your choice. Okay. Well, what I want to ask myself, can I add straight down and eliminate either the x or the y? Yes. If I add straight down, 2x plus -2x is 0. It's gone. So now I just have -5 plus 1y. You need to put that 1 in there because several you blow that, and you're going to write down -5y instead of -5 plus 1 is -4y. So if you're not an A and or possibly B student, you should be putting that 1 in there. Otherwise, you're going to forget. If you want to be safe, put it all in, no matter even if you have an A or B. I'm just adding straight down. 9 plus 3 is 12. Last step, divide by -4. And y equals -3. We're not done because when we solve a system, we're trying to find the point of intersection. A point is x comma y. So we just found the y coordinate. We need to plug this back in to either equation. I'll just plug it. I'll plug it into the top equation. So I have 2x minus 5 times -3, substituting in. Remember, whenever you substitute in, you put parentheses around it like that all the time. Whenever you substitute something in, better have parentheses around it. So now it says 2x and -5 times -3 is positive 15. Do not try to go too fast. You make one simple integer error and it blows your answer. The coefficient is positive on the x. I'm going to leave it there, which means the constant is moving to the other side. Same things I've already been saying over and over. So now I have 2x equals 9 minus 15 is -6. Last step, divide by 2. You get x equals -3. So now we have our point. -3 for the x and -3 for the y. And there's my answer. If I want to be sure, I could plug it back into the second equation. Negative 2 times negative 3 is 6. And 1 times negative 3 is negative 3. 6 minus 3 is 3. That checks off. Again, all of these you can plug back in and guarantee you're right. So it's 13. All right, 14, 15, and 16 are graphs back on the main page. So let's go back here, nice and quick. Y is less than 2. Whenever y equals a number, 2 that is, that's a horizontal line. You need to have that memorized. Now, I've told you over and over how you can make sure that you know it's horizontal. This says y has to equal 2. So I make an XY T-chart, y has to equal 2. Draw down 3 2's under y, because y has to be 2. X could be anything it wants. So let's just say 0, 1, and 2. Nice, easy numbers. Plot those 3 points. 0, 2. 1, 2, and 2, 2. And there's your line. Now the question is my line solid or dashed? Since there's no equal sign, it's going to be dashed. Arrows at the end. It says y is less than. Remember, it's pointing to the y. So y is less than. Whatever it's pointing to, that's the less than side. It's pointing to y is less than 2. Well, there's y is 4. That's greater than 2. Here's y is 0. That's less than 2. Less than is on the bottom side. So it's going to be shaded like this. Same idea when you have x equals a number. X equals a number. In this case, 0. It says x has to be 0. Put 3 zeros. Y can be anything. 1, 2, 3. So 0, 1, 0, 2, and 0, 3 right there. Again, no equal sign, so it's going to be dashed. Arrows at the end. Now it says x is greater than 0. So we want about the numbers on the x-axis. You got to know that's the x-axis. Here's x is 0 right there. Where are numbers that are greater than 0 on the x-axis? All these, x is 1, 2, 3, 4, 5. These are all greater than. So it should be shaded over here. 16. Y equals or is greater than 3x. Dang it. The sign went away. We'll make it plus 1. Okay. So slope, that's in slope-intercept form. Right as a fraction. Up 3, right 1. Y-intercept, 0, 1. 0, 1 is the point. So I plot the y-intercept as a point. Then I follow the directions. These are directions. These aren't points. These only give me directions to other points. I says go up 3, 1, 2, 3, and right 1. Up 3, right 1. I could also go, I can write it as negative 3 over negative 1, which would be down 3 and left 1. 1, 2, 3, and left 1. All those are lined up on a line. Okay, that is going to be dashed because, again, no equal sign. So there's that one. Let's move it down so you can actually see the second equation. All right, the second equation is in standard form. I've always told you what are the 2 easiest points to plot in standard form. The x and y intercepts every time. So x-intercept. That means y is 0. So cross it out. Y is 0. I get 3x equals 15. X equals 5. Okay, so 5, 0. Change the color. 5, 0 right there. Y-intercept. That's when x is 0. So again, erase that. Now x is 0. I get negative 5y equals 15. Y equals negative 3. So 0, negative 3 right there. There's my 2 points. That's all I need. Now, if you want to solve for y, you can do that and put it in slope-intercept form and graph it. Okay. If you want to plug another point in and plot it, so you have 3 points to make sure they're all lined up, you can do that. Make sure you haven't blown it. Okay. So this one is also dashed because there's no equal sign. Okay. So now I've drawn my 2 lines, dashed them because neither of them had equal signs. Now I'm going to show you how you shade. Since this is in slope-intercept form, I just go ahead and follow what it says. Y is greater than. Somewhere that was the red line. So greater than is in that region right there. Those are greater than any of the y coordinates above or below it, according to that red line. So it's either down here in this region or it's in this region. So now I look at the second one. Notice the second one, the coefficient on the y is negative. If it's negative, I must switch the inequality sign to greater than. So now I need that to be above the blue line. Well, if it's above the blue line, it's either in this region or it's in this region. Those are the two that are above the blue line. So now I just ask myself, where do I have two dots? What region up here do I have two dots? Only in this region right here, I had those two dots. This one down at the bottom, I had one dot, and this one up here in the upper right, I had one dot. Not good enough. It only satisfies one of the inequalities. It has to satisfy both of them. So that's what I'm saying. You could just put dots in there. Then I could always pick a point in there if I wanted to in that region I've shaded and plug it into both inequalities above, and it will be true for both. If you shade in the wrong region, it will not be true for both. Okay, last one, 17. I have that one on the last page here. Okay, so it says find the value of x if the mean is 11. You gotta remember the mean, another word for mean is average. You learn this for years. And how do you find the average of any numbers? You add them all up and divide by the total number of numbers there are. So I'm just adding this up. 6 plus 8 plus 17 plus 15 plus x equals my mean, which is 11. And remember, I have to add all those up and divide by the total number of numbers. How many are there? 1, 2, 3, 4, 5 numbers there. X is the number we're trying to find. That still counts as a number. That's the fifth number. So now we have this inequality. I'm sorry, this proportion. Again, we just cross multiply. Combine all these like terms first. 6 plus 8 is 14, plus 17 is 31, plus 15 is 46. So I have 46 plus x divided by 5 equals 11. Rule 1, cross multiply. I'm just doing 1 times that, so this takes it off. 46 plus x equals 5 times 11, 55. The coefficient on the x is positive, so it stays there. So I'm moving the constant across, minus 46 on both sides. And there's my answer. X equals 9. 46 plus 9 is 55. Okay, so x is 9. That will make the mean to be 11. All right. So there's all your work and all your answers. That's the first half of your final. Basically, I think I'm going to have around 35 problems or so in the final. There's 17 of them right there. Okay, there's different numbers. So now you've got that to use.